Welcome, everyone, to COG250, Introduction to Cognitive Science. Very glad to be here. I'm very excited about this course. This course is was one of my favorite courses to take in undergrad, so I'm thrilled to be teaching it again this summer. My name is Corey Lewis. You can call me Corey. This is my email address. As you can see, it's an old-style U of T email address because I have been at this institution since ancient days. I did my undergrad here as a philosophy specialist. I actually did my very first philosophy of mind class in this classroom. It's a nice nostalgic classroom for me. And then I did a PhD at the Institute for the History and Philosophy of Science and Technology. And now I'm a lecturer in the philosophy department and a sessional lecturer here in the COG-SCI program. So that's me. Email's the best way to get in touch with me if you need to get in touch. I try to respond within 24 hours. If I've failed to respond to you within 48 hours, please do email me again to remind me. I generally keep roughly inbox 0, so there's not like a long lineup of things for me to respond to. So if I haven't responded to you, it might just be that it's slipped through the cracks. So feel free and please do remind me if I've not responded to you promptly. Yeah, so that's me. Office hours will be, by way of introduction to the introduction, we do have some course content to get to today, so I'm actually going to attempt to teach you some things today, but first we're just gonna go over the syllabus, basic info, that kind of stuff, yeah? Okay, so these are my office hours right after class, basically. After either class, Tuesdays or Thursdays, and my offices is UC room F203, which, given the construction is somewhat difficult to get to this semester, I will post more detailed instructions on how to get there. Please let me know if you're gonna come to my office hours. You can let me know like right at the end of class. You don't have to give me any warning, but it's a fairly dank and dreary little office. So I don't want to just be sitting there for 2 hours a week all by myself feeling sad and alone. So if you could just let me know that you'd like to meet, whenever you'd like to let me know would be great, but let me know so I don't have to sit in my sad little office alone. Okay, okay. And just by way of mentioning, so getting in touch with me is a good way of answering any of your questions. Coming to my office hours is a good way of discussing any of your content questions. There's a really nice group of people called CASA. If you haven't heard of CASA, they will be your friends this semester, potentially. So this is the Cognitive Science and Artificial Intelligence Student Association. They're an incredibly energetic and engaged group of undergrads who kind of run support for this class on a volunteer basis. I don't know what drives them to do that, but it's incredible and very helpful for me and for you. So they'll be having office hours throughout the summer where you can go and discuss the issues that we were talking about in this class. So that's a really helpful resource. So you can go there just to discuss coursework. They'll be doing essay clinics, test prep. I mean, or at least that's what they did last summer when I taught this course for the first time. So they'll be around. So hopefully they'll come talk to us sometime soon to tell us when all that's happening. But this is another really great resource for you. Okay. So before I get too deep into this stuff, let me just do a quick survey about, so that's me, that's us. I'll talk a little bit about you, because this is an odd course in an odd little program. Just quickly, could I get hands up if you're in your first year? 1, 2, 3, 4, yeah, a smattering. Second year? Slightly more. Third year? About the same. Fourth? Great. And beyond your fourth year? I took 7 years to do my BA, don't be ashamed. But okay. So as you can see, there's a wide variety of where you're at in your degree. We're like normally distributed throughout a 4 years of your degree. Hands up if you are either planning to or are enrolled in the COG-SCI program. Like half the class. Great, great. How about psychology? 2 psychologists, welcome, welcome. Linguistics, yeah, a few. Computer science, bunch of comp sci people, welcome. And anybody I didn't mention there? Yeah, what are you? Math, whacker, okay. And yeah, stats and philosophy. Any other philosophers in the room? No? Potential philosophers? Okay, welcome. So that's, this, by the way, is secretly a philosophy course. It's not very secret because I just told you, but we're going to do a lot of philosophy of science. And this lecture, I'm going to explain to you why that's actually necessary for cognitive science. This is not a science like other sciences for a bunch of reasons, and we'll get into that today. Okay, so we got a wide range of where you're at in your degree. We got a wide range of majors, and that's just kind of how this course goes. So that means that basically everybody is going to be at least a little bit out of their element at some point in this course. Every one of you is going to feel somewhat like uncomfortable and like, ooh, what am I doing here? That's just how this course goes. Yeah? We'll see when we get into the syllabus. This course involves a lot of writing. So having done writing before is a big asset. That will be very helpful, but you'll also have to do some sciencey research, which is something that those skills tend not to overlap. Typically, the more sciencey stuff you've learned, the less writing you've learned. So the kind of sciences, humanities divide, and we're here smack in the middle. So this is going to be challenging for everybody, I think. I think this is going to be, and hopefully rewarding for everybody. Hopefully we can sort of take you a little bit outside of your comfort zone, and you can grow and learn. But that means that the course is specifically structured assuming that you don't have any specific background, right? We're not assuming that you know anything other than how to operate your legs to get to the classroom and listen and understand things, but no specific knowledge background is going to be assumed. We're going to start from zero. It's an introductory course. Yeah? Okay. I should note right off the bat, so this course that I'm about to deliver is basically identical to the one that was designed by John Verveake, who is more or less constructed the COG250 program at U of T. It was largely based on his doctoral dissertation and subsequent work. And I'm going to be following the structure, so the normal year, like the September to April COG250 class, this is basically the same class compressed into 4 months. So if you've heard of or know of that course, this is basically the same course. So the class isn't, in some sense, it's a survey of issues in cognitive science. Intro to cognitive science, part of the job is just to show you around the discipline a little bit, but it's also a kind of argument. So this course is going to make a continuous argument throughout the semester for a specific point of view in cognitive science, and it's the point of view advocated by Professor Verveake. I think it's a really helpful and interesting view. It's not one that you actually have to endorse to do well in the class. This is an argument for an approach to COG250, but it's not the approach. It's not that that approach is mandatory for you right now, but I am going to be advocating for it. I am going to be trying to convince you that this is a helpful and interesting view. And if I had to sum it up, it would be something like caring about the world is inseparable from thinking about the world. That's more or less the thesis of this course, that having interests and values and seeing the world as relevant is not something that you can separate from human level cognition. That's roughly the thesis. We will come back to that in great detail if that was not super clear. But so that's the main thing we're going to be doing, roughly a survey of issues in cognitive science, but also using a kind of argumentative structure to build on that survey. That's what we'll be doing. If you want to take a quick look at the syllabus, you can see the schedule. I particularly like to draw your attention to the schedule where we've got a few things kind of correlated. Dates, the broad topic of the lecture, and the readings, as well as the assignments. So this is the second to last page. So every class will have a topic. The topics are more or less listed there. probably if you haven't got any background in this stuff, the topics will be opaque to you. You'll say, okay, what is unsupervised learning? I don't know what that is. We will explain it as we go along. Every class has a reading associated with it. They're listed there. All of those readings, except for the textbook, are on Quarkus now. So everything is online, except for this book, Mind and Machine. Yeah?
That book is available free through the U of T library site.
Fantastic. Fantastic. That's very good to know. So what I'm allowed to post on Quarkus is 2 chapters of any given book, or like less than 20% or something like that. And I'd like you to read 6 chapters of this book. We're going to get pretty deep into it. It's a lovely little book. It's very well written and insightful. But I'm not allowed to post 6 chapters of this. But I've just been informed that U of T Libraries carries this online. Now, if you would like a physical copy, I've ordered them from the bookstore. They should be arriving well before we need them, about halfway through. So we're going to start reading this in June. I love having a physical copy of things. When I have to read something really hard, I'll print it out, and so I can like write down things in the margins. This is, according to the psych research, you get better retention if you've got a physical copy. But if you would like to save, I think it's $30 or $40 or something like that, if that's your priority, then get it from the library website. Yeah? Okay. That is very good to know, by the way. Okay. So I made this disclaimer at least partly because I'm going to do the following. I'm going to be recording these lectures and posting the recordings to YouTube, technology permitting. So I've done this for a number of my past classes. What I'm doing, this little mic here is recording my voice, and I've got a thing recording the slides. I'm just going to put my voice over the slides. So there's no video recording going on. There's no video being recorded, but the audio is being recorded. Your voices come through. If you say something in this class, it'll be picked up a little bit by the audio recording. The good news is that nobody watches these videos except people in the class. I can tell by the view counts, because nobody on YouTube wants to hear 20 minutes of me going on about a syllabus that's not relevant to you. So it's really not like, this is not going viral, don't worry. But I hope that for you, this is a useful resource to have. So you'll have the lectures over the slides all recorded. I'm also posting the slides, the PowerPoint slides on Quarkus. I'll try to do that well ahead of time. I haven't managed to post the ones for Thursday yet, but today's are up. And on hearing this, you are immediately tempted to never show up to this class again. This is what's going through your head right now. Like, oh, I never have to come to this class again. Great. I would certainly understand if you have something specific, you can't make it, or you're sick, or whatever. That's why those recordings are there, to help make this class more accessible to you. But it's also strongly recommended that you show up and talk to me, talk to us about this material. Everything that we know about learning suggests that showing up and participating is a vastly better way of learning. You spend much less time to do much more learning. Your learning will be much more efficient if you engage with the material with me. So it is, as a value proposition, your cost to benefit ratio is much better if you can get here and participate. And by way of warning, this is again a weird class in the sciences, because the kind of processing that I'm going to be asking you to do is depth processing. I'm going to be asking you to try to deeply understand this stuff rather than just say facts back to me. Yeah? Like, and we'll, as a matter of fact, we'll talk quite a bit about things like memory and levels of processing and understanding and all that stuff. This will be part of the course content. But so I strongly recommend, the moral of this little story is, strongly recommend that you come show up. Yeah? Strongly recommend. Okay. And these are 3-hour classes. Typically during the year-long, when this is not a compressed summer course, but the regular semester course, it would be 2-hour lectures and 1 hour of tutorial per week. So we've basically rolled tutorials into the lecture. This is where we're going to do our discussion as well as presenting the material. So hopefully, I'm really hoping that you'll be willing to talk about this stuff with me. I think this stuff is fascinating, and it hopefully we present it in a way that you can disagree when you disagree, or question where things are unclear, that kind of thing. So this is a combined lecture tutorial style thing. Yeah? Okay. Okay. One other thing about lectures, so the plan will be, these are 3-hour lectures. I don't even watch movies that are 3 hours long, so I'm going to never make you sit here more, the goal will be to never make you sit for more than 50 minutes continuously. So we'll do like 50 minutes of lecture, 10 minutes of break, 50 minutes lecture, 10 minutes break, 50 minutes of lecture. Very often we'll go the whole 3 hours. I'm not gonna say we'll do that every single time, but like do expect to do the 3 hour, be around for 3 hours, although never 3 hours continuously, because oh man, who can do that? Okay? Okay. Quickly, we'll just go through the structure of the course, the assignments, and all that kind of stuff. So there will be 2 term tests, 2 essays, and an exam. That's everything that you're going to be evaluated on. So the term tests, as noted on your schedules, will be July 6th and July 23rd. They'll be during regular class time, so they'll be 1 to 3, or they'll be 2 hours long, so from 1 p.m. to 3 p.m. Location TBA, that is to say, I don't really like this classroom for writing tests in. Your desks are weirdly, they're not very deep, and you're also kind of packed in here. So I put in a request for exam center rooms. I have not heard back yet, but I'll let you know as soon as I know. The worst case scenario is we'll write in here, but if we can get a better room, that would be nice. These tests are the following basic format. Test 1 is 6 short answer questions. They're not that short of an answer though. I don't want you to think that you can just write 3 sentences and be done with it. It's a 2-hour test with 6 questions. So I'm expecting quite a bit from you on each of these things. And I've, in the syllabus, if you want to take a look, I've given some details on how, so the term tests will be structured, what we're kind of looking for. What I'm going to do basically is give you a list of 10 terms, central terms, important terms from the course, and you're going to pick 6 of them, and you're going to explain them to me. And by explain, I do not mean define. To define something is just to give the necessary and sufficient conditions for being a thing. To explain a thing is to show me that you understand it. And that is a much harder thing. It takes a lot more time and space. To explain something is to draw out connections between it and other things, to tell me about arguments that it participates in, to tell me about how it's related to other ideas, tell me about things that are been leveled against it, arguments against that idea, or arguments for it, that kind of thing. So a lot of rich contextual background that you're going to bring out for me, rather than just telling me what the thing is. Yeah? Okay. So test 1, 6 short answer. Test 2, we'll do 4 short answer, again selected from 10, and then 1 essay question chosen out of 3. Essay question is just like a longer version of this. Yeah? Fairly clear? We'll talk more about this as they approach, of course. Yeah. All right, you got 2 essays. July 2nd and August 8th. August 8th is the very last day of class. So there'll be a short essay and a long essay. Short essay, you're going to be given the topics. You'll select from a short list of topics. You're going to defend in the long essay. Here's the catch. You're going to generate your own topic on the long essay. You are absolutely welcome and invited to talk to me about, if you're like, I don't know how to do that, I've never had to do that before, please talk to me about generating your own topic. But this is part of the assignment, is figuring out where your interest lies in the course. Part of the assignment is framing your own question, which, as we'll discuss at great length, is one of the hardest parts of thinking, coming up with a good question. It's one of those parts of thinking that becomes invisible when you are handed questions, or when the question is just obvious to you. Generating a question is a genuinely hard thing to do. It's a genuinely hard thing that I'm going to ask you to do throughout in this course. So that should make you at least a little nervous, because it's genuinely hard. Yeah? Yeah.
Do you have any specific
So are there any specific limitations to questions? The main one is that it's got to be relevant to course content. The main one is that it's got to be related to this course. People are often tempted to just kind of write about something else, and that's going to be something that I'm going to say no to. If you have any doubt about whether your topic is related to course content, just get in touch with me and I'll let you know. That's the main one. So if you can tie it into this course, practically anything is fair game. Yeah. Any other questions about this? Or anything we talked about? No? Okay. Both essays will be evaluated on the following 4 broad headings. So the quality of your writing, this includes spelling, grammar, paragraph structure, doing the citations properly, formatting it properly, all that stuff. Quality of your research. So both of these are going to involve at least some research, and I'll give you a little bit of guidance on if you've, there are people here for whom that sounds fine. There are people for like, no, research. So we'll talk a little bit about how to perform this research as we get closer. Integration of course content, that is a worrying amount of the time I get people saying things in their essays that shows a shocking lack of integrating what we said in class. So if I make an argument to you, it's not that you have to agree with my argument, but I want you to show me that you're aware of it and have responses to it at least. Don't just ignore things that were said in class. So if I say memory is complex and you write in your essay, memory is a very simple process, that's a failure to integrate course content, right? So that's what that is. And then the quality of your argument, just how convincing of an argument have you produced? Are the premises reasonable? Do they lead to the conclusion? That kind of thing. Okay, so your essays will be evaluated on these 4 things equally. So I'll assign a mark. What I'll do is you'll hand your essays in to me via Quarkus. I will mark them as quickly as I can. I'm, by the way, doing all of the marking for this course, so I'm both the instructor and the TA. And I'll make comments throughout, and then a final global comment at the end where I make some global comments and then give you marks on each of these segments. So I'll tell you how well I thought you did on all 4 of those portions of the mark. Yeah? Okay, so that goes for the short essay and the final essay. Good so far? Good. Yeah, I said this already. Oh yeah, plagiarism. Please do not. We will talk in more depth about what counts as plagiarism as we get closer to the essays. I posted an anti-plagiarism checklist on Quarkus. If you are in any doubt whatsoever, please ask. I'm going to put your essays through Turnitin. This is automatically, you don't have to submit it to Turnitin, you just submit it to Quarkus. Quarkus puts it through Turnitin for me. I used to really dread putting people through the plagiarism process. I'm getting used to it now. It's okay. I don't mind. Mostly the thought that motivates me to do that is that the only thing in the world that I have to sell is my words and ideas. That's all I make these days. It's basically all I've done for my entire professional life is make words and put them in the proper order. And if you take that from me, you've taken the only thing that I have. Yeah? And I will spend the time and energy to defend that institution of people getting credit for their words and ideas by, if necessary, demolishing you as thoroughly as I can. So let's not do that, shall we? Anybody who I've ever done for plagiarism tells me the following kind of story. They say, it was the last minute, I was panicked, I didn't know what to do, so I plagiarized. If you find yourself in that situation, here's what you should do. Email me. Tell me, I'm up against a wall here, I'm panicking, I don't know what to do. And probably I will give you an extension. Like we can work, that's a problem that we can work with, whereas you plagiarizing is a problem where I will send you up the chain of command and they will make your life hard. Yeah? Okay. Final exam. Final exam will have the same format as the second test. One of the reasons why I'm giving you the second test in the format that I'm giving it to you. It'll be short answer questions and then an essay question. Final exam will be 3 hours long. Okay, So that's all the evaluation stuff. There's no participation marks, there's no attendance marks. I hope that you will come here voluntarily of your own free will because it's a good use of your time so that you can get the most out of your education. Yeah. Good with that? Okay. We talked about this already. The readings will be posted to the course website. That is, they are already posted to the course website. A note on the readings. So I've given you some hard readings. I've given you some genuinely challenging readings, especially if you're not, for the first half of the course, if you're not from a psychology or a science background. I've given you some primary literature from psychology. And if you're not used to that, it will be a slog for you to get through that stuff. It might be to your benefit to wait until after we've done the lecture on that material and then read it. Because then you'll have I'll do my very best to give you a nice framework for dealing with the ideas. Why are they having this argument? Where did this argument come from? What are the stakes of this argument? With that in place, it should be easier for you to deal with the readings. I consider all of the content of all of the readings technically examinable. But with that said, the tests and the exams overwhelmingly focus on stuff we've talked about in class. So, and if you recall the format of the test, what I'm going to give you is a list of 10 major concepts from the course. Major concepts from the course are not things that are hidden on page 52 of one of these papers, right? Okay, so the big ideas are what you're looking for, right? The big ideas are what we're going to talk about in class. The readings are helpful to understand more deeply what's going on, and they're especially helpful when you start doing your research for your papers, but the focus for the tests and exams will be on stuff that we've discussed. Yeah? Okay. Okay, quick questions or anything? How are we doing? That was basically the rough overview. Let's quickly do, I would like to, as a kind of, so that was the syllabus stuff. If there's any other questions about course structure or anything like that, just briefly want to take a look at the schedule and talk about what the pace of the course is going to be, how we're going to move through the various topics. So, because there's a structure here. So from now until June 6th, June 6th is our first test. Basically what we're going to be doing is psychology. We're going to read a bunch of psych papers. We're going to go through overviews of issues in problem solving, memory, and categorization. Sorry, first categorization, then memory, then problem solving. So those are three main big topics that we're going to deal with. Cognitive psychology broadly, that is, how do we come up with ideas? How do we categorize things? How do we remember things? How do we solve problems? So that's the first roughly third of the class. That'll bring up a whole bunch of issues, a whole bunch of questions, unresolved questions for cognitive science. And then we're going to shift after the first test to talking about artificial intelligence. We'll talk about artificial intelligence roughly from June 11th to, I guess, to the second test. So between test 1 and test 2, we're largely talking about artificial intelligence and attempts to formally describe the mind using machines. So that's about a third on artificial intelligence. And then the final third of the course, we're going to go straight into philosophy. We're going to talk about the metaphysics of mind and consciousness and all that stuff. So basically the course has a three-part structure: psychology, AI, philosophy. Okay? So locate yourself in that. Where are you going to be comfortable? Where are you going to be uncomfortable? This course is, it's a compressed course. We're going to be together like 6 hours a week. This is a whole year worth of stuff in 4 months, or 8 months worth of cognitive science crammed into 4 months. I hope you've got some time blocked out for this. This is going to be some work. We'll be together a lot, and the stuff is going to come fast and quickly, so I strongly recommend that you keep up with the course. This is a bad course to fall way behind in, at least partly because of that thing that I said at the beginning, which is there's a kind of argument running throughout the course. And if you lose the thread of that argument, it's hard to get back on it. This is what lots of undergrads have reported. If you allow yourself to get lost, it becomes harder and harder to get unlost. So do keep up. Try your best. Okay. Okay, so that's the kind of formal syllabus stuff. I propose now to take, we've only been at it for half an hour, but let's take 10 minutes. Let's take 5 minutes. Should we start again? I take it that hopefully throughout the semester we'll be doing 10-minute breaks because we'll be delivering a lot of content and you need time to digest it. I take it that going over the syllabus wasn't too taxing of an activity. You're all aware of the idea of tests and essays and stuff, right? Okay. So we'll just do a quick, I'll just take a 5-minute break here and we'll do some stuff. So we're going to spend some time right now thinking about this question of what is cognitive science. This is not an easy thing to answer, frankly. And it's a kind of different science than most of the other sciences that are taught at universities. So the slogan answer is the interdisciplinary study of the mind. And I bet that sounds like I just gave you an answer to what cognitive science is. But I didn't. That's not an answer. Well, it is an answer, but it's a horribly vague answer. Does anybody see why that's an incredibly vague answer? Thoughts on this as an answer? Like, are you satisfied with this? Or like, does it clear? If I told you this, are you like, oh yes, now I know what we're doing? Yeah.
It doesn't give us a problem that we're looking to solve.
Right. Right. What exactly is it that we're trying to deal with here? Like the interdisciplinary study of the mind. Any other worries about this as a definition? Yeah. Yeah, what are the disciplines? That's a really important question here. Which are the disciplines that are being interdisciplined? Yeah.
What do you mean by mind?
What's the mind? Yeah, that's so far we've got problems about interdisciplinarity. We've got which are the disciplines, and we've got problems about mind. Those are the two main components of this definition. So both of the main components of this definition are unclear. And study. We're also, what is it that we're studying in the interdisciplinary study of the mind? So literally all of the elements of that definition I just gave you, which sounded like a definition, are very unclear for us. Okay, so let's start here by thinking about which disciplines are involved. I've given you some hints by putting this lovely graphic. This is a kind of standard thing. If you Google cognitive science, this is the kind of image that pops up. So what do we got here? We've got psychology, philosophy, linguistics, anthropology, neuroscience, artificial intelligence. A kind of grab bag of disciplines. Okay. So fine. What is the mind? I told you this is secretly a philosophy course. This is exactly the kind of thing that philosophers do. What is the mind? Well, okay, so one really common way of thinking about this is the mind is what your brain does, right? The mind is a brain function. It's a function of your brain. It's brain activity. Good, so that's neuroscience, right? Neuroscience tells us about the brain, therefore neuroscience studies what the mind does. Good. Except neuroscientists don't really study minds, do they? What do they study? They study brain anatomy, the activity of neurons. Is that what you mean by mind? Is that all that you mean by mind? The activity of neurons. Flatworms have neurons. Do they have minds? They've got about 102 neurons. Does that constitute a mind? How would you know? Can you ask neuroscience that answer to provide the answer to that question? Unclear. It's very unclear. Here's another thing that you might mean by mind. The kind of thing that you use to produce thoughts and beliefs, to generate behaviors. Now, in that description I just gave you, no mention was made of brains, right? So A psychologist studies the mind, don't they? That's ostensibly what psychology is, the scientific study of the mind. But in a psych study, very rarely do they crack open people's skulls and look at their brains. Sometimes, I mean not crack them open, they scan your brain sometime. But most psych studies that are run have you, a whole individual, sit down in front of some task or stimulus or something like that and behave in various ways, right? You press a button, or you say a thing, or you move around a space, right? You behave. What psychologists study is behavior, typically human behavior these days. Used to be more rat behavior, but the behavior of whole organisms, not really, or not typically, their neurons. Right? So it seems like psychology and neuroscience are studying quite different things. But how likely do you think it is that you're going to completely work out what's going on in the brain without knowing about things like thoughts and beliefs? Like, not likely. It's not super, like, I find it to be fairly unlikely that we're going to have a complete science of the brain, of the human brain, without ever mentioning that these beings that have these brains have views of the world. They have complex ways of thinking and interacting with the world which elicit behavior. You're not just going to have a brain in a jar and be able to study it in isolation, are you? Because the way your brain behaves crucially depends on your interactions with your environment, your behavior. Consider also linguistics. So linguistics, what are one of the main ways that you tell somebody that somebody or something has a mind? Well, you talk to them. Maybe not necessarily, like you don't necessarily need to talk to somebody to know that they have a mind. You can observe their behavior. But without language, like language is one of the crucial ways that you know somebody else has a mind, right? And think what your mind would be like if you didn't have language. So, how many scientific facts would you say that you personally have verified? How many of the facts that you believe that I believe that gravity pulls things down. I believe that stars are made of hydrogen undergoing fusion. I believe that birds aren't mammals. Like, these are all scientific facts. I have verified none of them personally, right? How did I get all these beliefs, which affect my psychology, which affects my neuroscience? Well, from language. People told me stuff. And how did that language come about? Like, where is this language coming from? Is it just built into our genes? Of course not. It comes from some sort of society, right? We are social creatures above all, right? Like, ask yourself, why is it that we're in charge of this planet? How did we get to be in charge of this planet? Look at us. I'm just kind of like soft and squishy. I can't run very fast. I have no claws. I have no big teeth. A single human is a sad little animal. Most of the other large mammals on this planet could easily kill and eat us. 20 humans who can talk to each other and think and plan are the most dangerous predators on the planet. We took over this planet because we have social structures organized around language that let us do things like iteratively plan and learn how to make a pointed stick, make a slightly better pointed stick and tell all your friends, come up with a good strategy for hunting mammoth, and tell all your friends, communicate to them, organize, to link our brains together. So one of our brains all by itself isn't that different from other animals' brains. The thing that we did was link all of our brains up in this vast interconnected network. The activity of your brain is radically, radically different than it would have been if you didn't link up into a society via language. Okay. So, We've talked about psychology, linguistics, anthropology, and neuroscience from that chart. And what I've been trying to do is kind of make an argument to you that you're not going to, in some sense, finish any of these disciplines insofar as they are studies of the mind without connecting them up with the other disciplines. So, for example, do you think you could understand language completely, finish the project of understanding language without understanding something about social organization or psychology or neuroscience? Probably not. You're probably not going to just completely clean out the problem of understanding the structure of human language without understanding that it's a language that's embedded in a society, and it's a language that's being instantiated by something with a brain, right? You're probably not going to understand societies unless you know a little bit about neuroscience and linguistics and psychology, right? So each of these, insofar as each of these disciplines purports to study the mind, they are in some sense they're studying different aspects of the same interrelated phenomena. The mind is kind of all of these things, is the claim. And what we've been doing historically is mostly studying these things in isolation from each other. I mean, less and less every year. So the push to interdisciplinarity, the interdisciplinary study of the mind, has been rising and rising. This is a great thing. It's a great opportunity. It's very exciting. It's also extremely difficult to do. Interdisciplinarity is spectacularly difficult. I have been studying philosophy at this university for like 19 years now. I'm getting okay at it. I'm getting the hang of it. Could use another 20 years or so before I would say I'm really good at it. Another 20 to say I've mastered it, and then I'd be dead. So that's just to get one discipline. The problem of interdisciplinarity is how do you get somebody who is good at a whole bunch of disciplines? Or if absent that, how do you link together people from different disciplines? So maybe you don't need to get good at all of them, but you need to be able to connect your work in, say, philosophy with people working in other areas. If we're going to tackle this thing, this problem, so I tried to make a brief argument for you, more of a sketch of an argument, but a brief argument for you, that if we're going to accomplish this study of the mind thing, it's probably going to have to be interdisciplinary. And that chucks us into the quite difficult problems of interdisciplinarity. Very briefly, what is a discipline? Let's do some good old-fashioned philosophy science. So disciplines is a standard way of thinking about it from Thomas Kuhn. Have you heard, hands up if you've heard of this paradigm stuff from Thomas Kuhn? Oh, good. Okay, not that many of you, which makes me glad because now I get to tell you something new. So in Thomas Kuhn's very famous book, The Structure of Scientific Revolutions, he argues that scientific disciplines are organized around what are called paradigms. A paradigm is a set of assumptions, methods, standards of evidence, what counts as good evidence, what counts as not real evidence, what objects do you believe exist in the world, what you call your ontology. So there's a whole collection of background assumptions that comes with a standard science. And having a paradigm is amazingly helpful. You want to be within a paradigm. Being within a paradigm means that the jargon you're using is the jargon everybody else uses. So you don't have like the friction of translation trying to figure out what everybody's talking about. Being in a paradigm means that when you publish a paper, everybody knows what you're doing, right? So having the same background assumptions liberates you from having to try to explain your whole project from scratch every time you try to explain it to somebody. Having a paradigm means you're all working on shared projects with shared assumptions. Here's the catch. Cognitive science does not currently have a paradigm. We are struggling towards a paradigm. That means that even the basic assumptions that we're working with need to be questioned and interrogated. That's why that's why the intro to this class is philosophy of science. Whereas, if I'm teaching you the periodic table, there's no room for you to stand up and say, I doubt the existence of carbon. Prove it to me. Like, that's just not a discussion that needs to be had, right? Because everybody's on board with the basic assumptions of the discussion. Whereas and that's what you can do. When you have a paradigm, that's what you can do. It's a set of assumptions that you can kind of settle back into and just use transparently. Whereas if you don't yet have a paradigm, you really gotta struggle to get it together. Like, you really have to work to find out what should we be allowed to assume? What should the basic entities of our explanations be? What makes sense to treat as given, and what has to be interrogated and tested? When you don't have a paradigm, all of that is on the table. And it makes it exciting and very interesting. It's all up for grabs at the moment. Like, cognitive science is in the process of coming into a state of having a paradigm, hopefully. But it also means that this discipline is currently not really a discipline as such. It's a bit undisciplined at the moment, let's say that. Yeah. So, cognitive science is a hot mess. That's what I'm telling you. It's a hot mess. It hasn't really got its life together. Doesn't really know where it's going. It goes home for Thanksgiving and its aunts are like, what are you doing with your life? And it's like, I don't know. Okay. So that's where we're at. We're not yet a discipline. Okay. But I showed you this argument. The point of the argument that I just gave you was, somehow, if we're going to do this thing where our ambition is very lofty, what we're going to do is somehow bring together the different ways of seeing the mind into one discipline. Make a paradigm where we can connect up all of these different ways of thinking about the mind. That's the rather ambitious goal. Okay, so I'm briefly going to talk to you now about three visions of cognitive science. So 3 ways that this could go. There's generic nominalism. So nominalism is the view that there's just a bunch of stuff. There's no pattern or universals or organization. So on one way of seeing the discipline of cognitive science, it's not really a thing. There's linguistics and there's psychology and there's AI, and those are just separate practices. People who think this, and they're smart, respectable people do think this, they call them the cognitive sciences. There's a bunch of separate disciplines that all study cognition from various angles, and they don't really integrate. So one way it could go, this is one way that cognitive science could go. In this scenario, in this way of seeing how things are going and how they should go, it doesn't really end up being an integration. It's just a bunch of separate disciplines that for some reason have conferences together. There's not much integration going on. So that's generic nominalism. If the argument that I gave you just a couple minutes ago is a good one, this isn't going to cut it. If what we need in order to understand the mind is this integration, then generic nominalism isn't going to give us that. It's not to say that you can't do good work in neuroscience or anthropology or linguistics or psychology. Within the if generic nominalism is where we end up, you can still study aspects of the mind, but you're not going to study an integrated mind in any important sense. Okay. So that's generic nominalism. Hey, maybe we could do a bit better. So here's one that says that we're going to do some mild integration. Call this one interdisciplinary eclecticism. Interdisciplinary eclecticism. It's a bit like religious interfaith dialogue. So it's a very common thing for various religions to have big conferences that all come together and they talk to each other about their religious beliefs. And the point of those interfaith dialogues is not for anybody to convert the other people. So it's not that the Christians are trying to get the Jews to become Christians and vice versa. It's rather just to kind of build goodwill, check in, be friends, you might gain some little insights about your own view from the other view, but you're not really looking to like radically transform into just one big super religion. That's not what interfaith dialogue is about. That's not what they're trying to do. So, in the second vision of cognitive science, that's kind of what the relationship between the different disciplines is like, where, yeah, once in a while, you, the psychologist, and the linguists get together, you chat a little bit about what's been going on. If there's anything real exciting, you let them know. And maybe you get some little bits and pieces from the other disciplines, little bits and pieces that are kind of useful or interesting, and mostly you're just trying to stay friends. I would say that this is more or less where we're at now. This is, in my assessment, kind of where cognitive science is at the moment, where interdisciplinarity mostly looks like disciplinarity with joint conferences. That's kind of how it, in actual fact, currently works. And nothing wrong with this. I mean, it's better than not talking. Like, I know that this is a tales from ancient days, but like in the 60s, chemists and physicists didn't even talk. Like, the amount of interdisciplinary dialogue that we have going on right now is way, way more than it used to be, because we figured out that you can't just solve problems. Generally speaking, problems don't get solved. Problems don't respect disciplinary boundaries. They just don't. Generally speaking, problems don't care whether you're getting the same funding stream as the biologists or not. The problem didn't get the memo that we're supposed to all be in these neat little silos. So we're talking more between disciplines, but we're currently, in the study of the mind, not really at the point where there's a kind of fully integrated interdisciplinary study, where, you know, the paradigm within neuroscience transforms the paradigm within anthropology and vice versa. It's just not where we're at. This is probably, I would suggest, an unstable middle ground between generic nominalism, which is just we're all doing our own separate things, and the following, synoptic integration. So this is not, I would propose, a thing that is currently happening, but it's like a goal. I mean, if cognitive science is going to be a discipline, this is where it becomes an integrated discipline, where the paradigms of psychology and anthropology, linguistics, neuroscience, and so forth are all mutually transformed by each other. Like, the actual assumptions and like the beliefs and the ontology that happens within each discipline could actually be changed and mutated by each other, where they're actually integrated. This would be like the interfaith dialogue turning out that everybody just joins the same religion. They all make up their own new religion and everybody joins. I don't think that's a good idea religiously, but within the scientific disciplines, that would be kind of like, this is the sort of the paradise utopia of cognitive science that we dream of, where, you know, you really do understand neuroscience in terms of psychology, linguistics, artificial AI, philosophy, where all of these things genuinely not just give each other little tidbits of facts, but actually transform the way every science is done in such a way that it integrates these other sciences. So, I don't know, it's a goal. That's the project, I would say. And this is a project that we need to pursue precisely because of the incredibly ambitious goal that cognitive science has set for itself: the interdisciplinary study of the mind. Like, it's a wildly ambitious goal. It's a very exciting goal. It's a goal that becomes necessary because problems don't respect disciplinary boundaries. The problem of the mind especially seems to not respect disciplinary boundaries, which in some sense means that we have to not respect disciplinary boundaries. That's probably putting it too strongly, because like I say, I've spent my entire adult life just trying to get a hold of one discipline. It's really difficult to get like 6 or 7 under your belt such that you can be masters of a whole bunch and work them all together. We need to not just, in some sense, I guess the argument I'm trying to make to you is that we need to not respect disciplinary boundaries in the sense of we need to talk across them and actually listen across disciplinary boundaries. So actually pay attention to what's happening. From my perspective, this is the most important version of this, because I'm trained as a philosopher. A lot of the philosophy that goes on in the philosophy department is fact-free. They don't care what's happening in science. A lot of philosophy really doesn't pay attention to what's going on in the world at all. So they could have made the same arguments 400 years ago if they had the kind of logical machinery to do it. This class is a secret philosophy class, but only in the sense that philosophy is participating in all of this empirical work. So my favorite kind of philosophy is the kind of philosophy where we try to pay attention to what's going on in neuroscience, pay attention to what's going on in psychology, to actually be transformed by new facts as they come in. So if this is a secret philosophy class, it's a secret philosophy class in that sense, where we're trying to do kind of philosophy as an integrative way of thinking, of critically analyzing and integrating stuff. Yeah. Okay, so speaking of philosophy, speaking of integration, so let's talk a little bit about this integration. So we're gonna do an extended little thing on integration itself, thinking about why we want it, in what sense do we want integration, what do we want it for, what does it look like? So, the philosopher Philip Kitcher does some really good work on explanation. So what is it to explain something? And Kitcher says the following: to explain something is to unify it in some important way. So the classic example of this is, of course, Newton. So before Newton, there were terrestrial mechanics and celestial mechanics. So there's a bunch of rules about how objects on Earth move, and then a totally separate set of rules about how objects in the sky, that is the stars and planets, move. They were unrelated disciplines. And you can see why. I mean, the stuff in the sky at that point, where they were just dots moving slowly across the sky. So the rules that governed them probably didn't have much, as far as they could tell, with the rules that tell you how a thing falls here on Earth. Okay. And then Newton comes along, and Newton says, hey, I have a set of rules, mathematical rules, that do both. I can tell you why Venus is moving the way it's moving, and I can tell you why that cannonball is moving the way it's moving. That is an incredible unification of apparently radically separate parts of the world. So, and in this sense, Kitcher says it is explanatory by showing you how that stuff, how Venus and Mars follow the same rules as cannonballs and kids being pushed on tricycles. You've explained by unifying. That's Kitcher's claim. Think about F equals ma. What a great rule that is. What an force equals mass times acceleration is such an amazingly unifying rule, because you can apply it once you know how to cannonballs, kids being pushed on trikes, rockets to the moon. It's incredible how many different phenomena you can apply F equals ma to, right? So it's integrative in that sense. That is, in the sense that you can bring a whole bunch of, so it's a way of framing problems. This is what integrates. So if you hadn't learned any physics at all, I assume you've all done a little bit of Newtonian mechanics in high school or whatever, or much more maybe. So if you hadn't done any physics at all, it might not be clear to you how to formulate the question, how far and how fast is that kid on the tricycle going to go? It might just be unclear. You wouldn't even know what the right question to ask is, what the right formulation for that problem is. But if you have F equals ma, it's a really robust way of formulating problems. So you know how to begin. So, I mean, you need to add in some bits and pieces to get an accurate calculation here, like what's the friction on the wheels, what's the air resistance and stuff like that. But once you have F equals ma in your head, you know how to proceed on formulating the problem in a way that you could potentially solve it, right? And you know that not just about this phenomena, but about that phenomena and the other phenomena and so on. You can do it for pendulums and all, like everything. Apples falling from trees, so on and so forth. So it's integrative in that sense. Okay, and that's part of what makes us feel like we understand it, right? Because understanding is in some sense having power over things. Like you understand things in order, at least partly in order to manipulate them, to cause outcomes that you want to come about rather than outcomes that you don't want. Okay, let's think a little bit about, we'll do very briefly some stuff on the psychology of integration. Think about this from another perspective. Metaphors are a form of integration. Metaphors integrate information for you. They bring things together. Not in the same way as a scientific theory does, but just think about integration in general. They build bridges that afford transfer. They integrate information. So, what are you saying when you say Sam is a pig? What are you saying about Sam? He's gross. So we say pigs are gross. I'm going to take that thing that I know about pigs and transfer it to Sam. Something like that, yeah? Now, transfer is fickle. Transfer is tricky. It doesn't always work. The things that you're transferring between can't be too close and they can't be too far away. So for example, hornets are bees. How's that for a metaphor? Does that help you a lot? Did you learn anything there about hornets? They have wings, they're flying things, they're bugs, no? It's a bad metaphor, right? It's a terrible metaphor because the things that you're trying to transfer between are much too close together. Right, so for a good metaphor, you can't have almost identical things. Yeah? They can't be too far away either. Here's a metaphor. Arguments are chairs. And you think, what are you saying exactly here? What's unclear in this case is what transfer I'm asking you to make, right? So in the hornets or bees case, they were too close that you couldn't get an informative transfer. And in this case, they're so far away, it's just radically unclear what I'm asking you to transfer from one to the other. You can specify, of course. You can say, arguments are chairs. They must be well constructed and have multiple supports. Oh, okay. I don't like it, but I get it now, right? Okay. Okay, so just really briefly, this is metaphors as a form of transfer. So you do this all day long. You transfer information between domains all day long in all kinds of contexts, right? So transfer as integration. What you're doing is integrating what you know about chairs and what you know about arguments, putting them together and learning something new. Yeah? So this is a kind of basic cognitive process. This is a thing that you do all the time, all over the place. What we're going to think about, but the point here was A, that we do this all the time, B, that it doesn't always work, that certain things have to be in place, certain conditions must hold in order for transfer to work from one domain to the other and for you to get successful integration. So talk a little bit now about what it is we're looking for when we're trying to create an interdisciplinary science of the mind. What are our goals here? We're gonna have to start, we're starting really, really basically here. We're starting from first principles because we don't have a discipline to tell us what to do. If you're in chemistry, your discipline tells you how to formulate problems. If you're in cognitive science, we're still struggling with that, which is why we need to really go back to first principles. Okay, so here's what I think we want from our scientific theories. Here's what we want our scientific theories to look like. We want them to have this property, multi-aptness. Multi-aptness. Something is apt if it's good for doing something. Something is multi-apt if it's good for doing lots of different things. Yeah? So, a scientific theory is multi-apt if you can apply it to a bunch of different problems, right? Call that elegance. The elegance of a theory, in some sense, is just how many different things you can use it to do. One of the most stringent tests for a scientific theory is, can it apply to things that it wasn't designed to apply to? So if you build your theory to deal with some certain set of cases, and then you discover that it deals with a whole bunch of unexpected cases really nicely too, you just get shivers up your spine. Oh, it's so good. That's such a good theory. Ooh, love it. Because that's what we want out of our theories. We want them to be integrative in this sense, in this forward-looking sense of being multi-apt for dealing with a bunch of different things. So as we're dealing with different theories within cognitive science, this is one of the things that we're going to be looking for. We want our theories in cognitive science to be multi-apt, to describe, to tell us, and to be informative about a bunch of different aspects of the mind. Okay, but that's not enough to just have that property. We also want our theories to have this convergent evidence leading into them. What we want is many different lines of evidence all supporting the theory. Just being multi-apt isn't quite good enough. So call this trustworthiness. This is about the reliability of your theory. The reliability of your theory is this is another kind of integration. In this sense, what we're integrating is lines of evidence. So the lines of evidence that support the theory should likewise be integrative in this sense. You intuitively want this. I promise you. So, like, you picture like kids at the movies when they're watching a 3D movie. They got the 3D glasses on, and they'll reach and try to touch the thing that they're looking at. And that's a very rational epistemic strategy. It's a very rational way of trying to understand the world, because one of your senses can often fool you. But if you get the same evidence from two of your senses, if you can see it and feel it, you're much less likely to be deceived, right? And we do the exact same thing in science. This is my favorite example right now. Call it multimodal evidence. Is everybody familiar with the LIGO detector? This is my favorite. Yeah. This is my favorite thing in science in the last couple of years. So they've got these two laser beams going off at right angles and bouncing back to measure very exactly the distance between the origin and there's a mirror at the end to bounce it back. Extremely precise measurements of the length, the distance that those lasers are traveling. And they use it to detect ripples in space-time. Literally ripples in space-time. So when, for example, two black holes merge, they create a distinctive pattern of ripples in space-time carrying huge amounts of energy. And these things can detect it. They can tell. It's like listening to space. It's amazing. So it's like they're able to hear the sound of space-time rippling. Okay, so that's great. That's one kind of evidence. The really exciting thing for my money is that in the last couple of years, they're starting to be able to correlate things detected with the LIGO detector and traditional electromagnetic telescopes. So like you can say, ooh, we heard something on the LIGO detector. Point your telescope there and see if there's something there. And they're like, yeah, there's something there. They can see the X-ray radiation from the thing that produced the waves in space-time. So you got multimodal evidence, converging evidence on the same phenomena. And what that gives you is trustworthiness of your model, right? That's multiple lines of evidence all coming together, all converging together on the same thing. So here's what we really want from our theories. We want our theories to have both of those things. We want them to have converging lines of evidence supporting them, and we want for them to be multi-apt. If it's got both of those things, For the purposes of this course, let's call it plausible. Please distinguish something being plausible from it being true. This is going to be an important distinction for us because, like, all we can do in science, typically all we can do in science is come up with more and more plausible theories. That's what we got. We got increasingly plausible theories. The question of whether they're true or not, kind of don't worry about it for the moment. Like, the closer you are to, and this is something that's obscured by the standard textbook ways of presenting science, because in the textbooks, what they give you are the bits that they are most confident are actually true. Carbon has such and such a atomic weight. You know, birds fly. Like the real established stuff. And that's just not what's on tap for cognitive science right now. That's just not what we've got. We don't have the clearly textbook, obviously true facts. What we have are a bunch of theories that are being set in competition against each other and measured on basically their plausibility, right? So we're looking for the most plausible theory. We make our various theories compete, and we continue to pay attention to and do research on the most plausible of those theories. We give grants to the most plausible theories, and that's the best we can do right now. Okay. Time. All right. Okay, so we want this integration. We want an integration. Why do we care about, so in general, we want our knowledge to be plausible. That is, we want converging evidence, we want to integrate evidence, and we want multi-aptness. That is, we want to integrate, we want our theories to be integrative in the sense of making predictions that turn out to be true. A question, but that's general to all of science. So what about cognitive science? Why do we want this particular integration? One pretty good reason is that currently we do not appear in the scientific worldview. Of course, we do in the sense that we are living things, we are mammals, we're made up of hydrogen and nitrogen and carbon and oxygen. Those things appear in the scientific worldview. But we as agents do not. There's no place currently in the scientific worldview for all of the best parts of you. The parts of you that, for example, understand the world around you. We don't have a scientific theory of understanding. We don't have a scientific explanation for how you generate scientific explanations. We have no place in science for agents who care about the world. We're working on it, but we'll do a little bit of the history of science, and what we'll see is around the scientific revolution, we got rid of things like purposes and goals and meanings from the scientific worldview. We eliminated them. I mean, Aristotle's world was full of purposes and goals and meaning. The goal of a rock that you drop is to get back to the earth. That was literally his physics. The goal of fire is to get up to the heavens, because that's where it likes to be. His world was full of purposes and goals and meaning and reasons and all this stuff. And then around the scientific revolution, all that was banished. But where does that leave us? The suggestion, so there's two ways that you can deal with this. One is you can eliminate us from your worldview. You can say, yeah, well, actually, there are no reasons or purposes or meaning in the world. That's just all gone. None of that's really real. We're all just atoms swirling around in the void. That is one way you can deal with this. That's kind of the standard way these days. There's another way that you can deal with this, however, which is to rethink the scientific worldview. And that sounds radical if you haven't done any history of science. But I absolutely assure you that rethinking the scientific worldview is a thing that happens and happens and happens. It has never stopped happening. We have never stopped rethinking the scientific worldview. That's kind of what science is. What we would like is a theory of the mind that satisfies the following. Call it the naturalistic imperative. This is a term offered up by John Verveake, who designed this course, but it's an ideal that's accepted by practically everybody in the cognitive science. So he's just putting a name on something that is quite pervasive already, which is what we want is a plausible theory, plausible in the sense that we just talked about plausibility, that satisfied the naturalistic imperative. And the naturalistic imperative is the imperative to analyze, formalize, and mechanize cognition. So let's talk about analysis, formalization, and mechanization. That is, these are essentially the conditions under which we could bring like us as agents into the scientific worldview. Okay. And to talk about this, I would like to talk about 3.5 scientific revolutions. Again, the people who are in science but don't learn about science tend to think that it is a finished product. And it is not a finished product. It has never been a finished product. We have been working on science for hundreds and hundreds of years, and the work has never stopped. So the tendency is to talk about the scientific revolution. Let's instead talk about 3 steps in the development of science, and with any luck, the next step that we're on the brink of taking when we deal with the mind. Okay, hang on, this is going to get weird. Thanks for hanging in, everyone. I know it's bad etiquette to produce course content on the first day, but this is one of those compressed courses, so we got to get to it. Okay, so we're talking about the naturalistic imperative. Here's what we'd like to have about the mind. We'd like to have a plausible theory that analyzes, formalizes, and mechanizes cognition such that we can find a place for ourselves in the scientific worldview. That would be nice to have. Science is, of course, an ongoing developmental process. We're about to do the shortest history of science in the history of histories of science as we review how we got to where we are in the scientific methodology, just really briefly talking about analysis, formalization, and mechanization, and then talk about where the next steps look like they're going to be. So prepare for some very, very brief history of science. Starting way back with Thales. Thales is an ancient Greek philosopher who said the following: all is the moist. The lodestone has psyche. Everything is filled with God. Yeah, it's great, right? So what does any of that mean? The argument that I'd like to make is that these are the very kernels of the method of analysis. So analysis is currently fundamental to the scientific project. Analysis means taking some weird, big, complicated thing, breaking it down into its parts, and understanding it in terms of its parts. And I would like to propose to you that Thales is doing analysis here. He's not doing great analysis by 21st century standards, but the alternative to this style of thing was literally like narratives. So mythological narratives that go like, there once was a god that ate all his children, and then another god cut his penis off, and then that became the moon. Like that was the structure of explaining and understanding the world. This was very much the way that the world was grappled with before this time. And then kind of all around the world, but we'll take an example from ancient Greece, people started doing this analysis. So he says, all is the moist. Something like everything is made of water. Well, Turns out everything's not made of water, I'm sure you're aware. But his attempt here is to understand the basic nature, the basic properties of all the things around him. You're an ancient Greek guy, your country's surrounded by water, water falls from the sky, you're made of water, living things come from water. It's not a terrible hypothesis, given the evidence available at the time. So what he's trying to do is understand the basic properties of things. Saying everything is made of water is an attempt, at least, it's an early attempt, but it's an attempt to understand the basic intrinsic properties of things, and then to try to go around and understand the world in terms of those properties. The lodestone has psyche. What's a lodestone? What do you know? Okay. Yeah. Got it. Magnet. Suke, yeah. In ancient Greece, yes, it would be. I'm translating. Yeah. Okay. Yeah. So the lodestone has suke, or psyche, as I would say it. And this is standard. Yeah. Anyway. So the lodestone has suke. Lodestone is a magnet. It's a natural magnet. What do most rocks do most of the time? Nothing. They kind of just sit there, right? But a magnet has this very strange property that if you bring it close to another metal thing, it would go bonk by itself. An astounding proposition. Now, what other things move on their own? Living things, things with life. And here psyche doesn't mean, suke means something more like life than a mental life. So, here's an argument based on analysis. Based on a universal generalization about the intrinsic property of things, you can do the following argument. Things that move are alive. The lodestone moves, therefore the lodestone is alive. This is the basic methodology of doing analysis and then making inferences based on your analysis. Again, I don't love this as a sound argument, right? You don't think that this is a conclusion we should all endorse, but the method is there. The beginnings of the method is there. And everything is filled with God. I take it. The basic notion is everything is interesting enough to be studied. That is, that the world is full of wonder, the world is incredibly interesting, and you should go out and learn about it. Again, probably not the only guy to endorse these thoughts. He's not the only one doing analysis, but it's a nice example of what analysis is. It's understanding the essential properties of the bits of the world and using those properties to build arguments and understand the rest of the world. Yeah? Okay, so this is a kind of revolution. It's a kind of scientific revolution in the sense that it's a change in the way people tried to come to terms with the world, and it laid the groundwork for quite a bit more of development and understanding of the natural world. Nobody at this point called themselves scientists, but let's call this a scientific revolution. Okay, let's do another one. Let's do another scientific revolution. So that was analysis. We want to analyze cognition. We want to break it down into its parts and understand those parts. We also want to formalize cognition. So here's Descartes doing formalization. Descartes was a genius, a lazy, lazy genius. Descartes' favorite thing in the world was to sleep in late somewhere where it was warm. That was his favorite thing in the world. And current historical thinking suggests that what killed him was waking up early in the cold. He was the tutor to a regent who lived in a Nordic country. She made him get up at 6 a.m. in the cold, and it killed him. So one day, Descartes was doing his favorite thing in the world, which was lounging around somewhere warm. And the style of the time was for the walls to be tiled. So there's tiles on the walls. There's just a fly buzzing around. A fly moving around. He's just sitting there watching the fly move around. Lazy genius Descartes. And because he was a genius, like for most of us, seeing a fly wandering around the wall, that's the end of the story. Because Descartes is a genius, he notices the following thing. For any point where the fly is, I can describe that point by counting up the number of tiles and over the number of tiles. I can graph where the fly is. And on the basis of this insight, he generates Cartesian geometry, which we're all familiar with from elementary school, right? And high school, hopefully, right? So Cartesian geometry, mildly useful if you're trying to do geometry, unimaginably useful if you do stuff like science, where you're not just charting physical locations, but like things like abstract properties like force or acceleration and that kind of thing. So what Descartes produces is certainly not the beginning of formalization, but a revolution in formalization. He allows us to formalize a lot more of the world by taking geometry and making it algebraic. By connecting up algebra and geometry, Descartes allows us to formulate or to formalize much, much more of the natural world. So again, producing a kind of revolution in our ability to apprehend and understand the world. So formalization. Most sciences are at least mildly formal. There are very few sciences that have no formal aspect whatsoever. Some sciences are more formal than others. Physics is the formal science par excellence. It's incredibly formal. It's almost entirely mathematical. And that's really nice because it prevents a certain kind of, it prevents a whole bunch of errors of kind of muddy thinking. When you formalize something, what you do is take your intuitive concepts and lay them out in a way that's unambiguous. That's going to be incredibly important here because there are a wide variety of kind of cognitive errors that we can fall into, fallacies that we can fall into when we're thinking about our own minds. I'll just highlight one of them for you as an example, but like formalization allows us to know that we've said something clear and sensible rather than something that sounds like it's clear but really isn't. So here's an example of it. Something sounds like it's clear but really isn't. The homuncular fallacy. This is the fallacy. A homunculus is like a little person. So here's if you ask people intuitively, how does vision work? You put this out there. You say, well, vision is like a little internal projector. Right? When I see the world, it's like it's projected inside my brain. And there's a little man inside that watches the projection. That's kind of the Cartesian theater. Have you heard of this? Like the kind of like picture of how does my conscious awareness of my vision work? Well, it's a kind of internal theater where my vision is being played. But the internal theater metaphor assumes that somebody's watching the theater. And then you have to ask about that person, well, how does their vision work? Well, there's a little person inside of them that watches. And then how does that little person's vision work? Well, there's an even smaller little person. Okay, so, and you're all thinking, what kind of nonsense is this? What kind of fool would fall for this kind of absurdly transparent fallacy? And literally nobody thinks that there's tiny little people in your heads. But what we do over and over again, what very smart people much smarter than me, have done in the history of cognitive psychology, the cognitive science, is build a theory of how some intelligent process works that assumes an intelligent process. Right? So what we're trying to do is to get to the bedrock of cognition. We're trying to get to the point where you're not using intelligence to explain intelligence. Right? You're not using a smart process to explain how we're smart. You're using unintelligent processes to explain how we're intelligent. And we'll start in with this on Thursday when we talk about categorization. The temptation is overwhelming, seemingly, to when you build a theory of how something works, like categorization, you assume unconsciously, without awareness, some intelligent process. right? So how do you categorize things? Here's what we'll say on Thursday. Well, you judge how similar they are. Well, it turns out judging how similar things are deeply depends on how you categorize them. So what you've done is assumed the thing that you're trying to explain, like positing a tiny little person inside your head who watches your vision, with a tiny little person inside their head who watches their vision, and so on and so forth. So, and part of why this is hard is because we're reflecting on our own minds, and your mind is very kind to you and doesn't bother you about all the things it has to do to keep your life going. You don't want all of your cognitive processes to be conscious. You want almost all of them to be going on in the background. But because they're going on in the background, they don't feel like work to you. So you don't notice that you're doing all this work. Like judging how similar or different things are is a very difficult cognitive task because your brain doesn't present it to you as difficult. It just does it in the background automatically. You're like, that's not a thing I need to include in my theory, right? So how do we combat this? How do we combat the almost overwhelming temptation to posit intelligent processes to explain intelligence? Well, we do formalization, and we take a step further and do mechanization. Mechanization is the ultimate proof that you have not committed the homuncular fallacy, that you have not posited an intelligent process to explain one. Mechanization guarantees full formalization. Sometimes it can look like you formalized a thing, but you didn't. You just thought you did, because there's a little homunculus running around somewhere in your formalization. But if you can mechanize something, if you can build a machine that does the thing, then you've guaranteed that you haven't committed the homuncular fallacy anywhere. You've created a machine that goes through every step. If you can build a computer program, right? So Turing, one of the heroes of the computer revolution, kind of defines what it is to be a computer. We'll talk a lot about Turing throughout the rest of the semester. And he kind of kicks off the artificial intelligence revolution, or the project of artificial intelligence, hoping to lead to a revolution. So, one of the ways that we're going to try to test our theories, to try to constrain our theories, is to build machines that can do the thing. If you built a machine that can do the thing, then you know that you haven't smuggled in some intelligent process, right? Well, hopefully. Building machines that can do things has turned out to be an immensely valuable source, not only of knowledge, but of questions. So when we do, in the kind of middle section of this course, we'll do the history of artificial intelligence. What we're going to see is that as soon as we started trying to build intelligent machines, we got a greatly increased respect for how hard intelligence actually is. Like, it looked like an easy project. In the summer of like 57 or something like that, some of the top minds got together and thought, they put a statement saying, yeah, we think artificial intelligence should take 3 months. I'm betting about a dozen of us. We got some pretty good computers. It's the 50s, we got good computers. I'm going to call it a summer worth of project to work out artificial intelligence. We should be all cleaned up by then. And when we started trying to do this, what became revealed to us was all the stuff that we hadn't thought about, all the stuff that was in the background that your mind just does for you that we needed to work out. So mechanization not only tells you that your theory is clearly not hiding homunculi, but also reveals the problems. That's going to be the main sort of thing that AI is going to do in this course. Reveal how hard the problem really is, because when you try to build the thing and it fails, you can see where the failure was. So the failures are as important as the successes as far as AI goes. Okay, so what we're looking for is a plausible theory with which we can analyze, that is, figure out what the basic constituents of the mind are. We can formalize a theory, that is, create a formal structure that with any luck, we can then mechanize and actually build a mind, a full-fledged mind. That's what it would be nice to, like, that's the goal. And if that works, then we can fit ourselves into the scientific worldview. That is, we can understand how cognition fits into a naturalistic worldview, a world where we don't have to posit a mental substance. We don't have to say that there's some radically different sort of rules about mind. We can figure out how us as agents fit into the world. Okay. That's probably enough for today. All right, good. So come on Thursday, we'll do concepts and categorization. We'll start it on psychology.